Good day, viewers all over the world. You are welcome to Toydel online class. Today, we want to start with the example on linear integrals. Of course, we know we have given explanation on linear integrals. And we are made to understand that the linear integrals along a point C, let's do C, is given as P dx plus Q dy. That is what a linear integral is. Then if this is a linear integral along 2 points AB, this point C, the linear integral along this C, the coordinate of x here, let's say is A1, B1, and coordinate of B is A2, B2. Then it will be, this will give us A1, B1, A2, B2, then P dx plus Q dy. So P is a function of x, then Q is a function of y. So that is the formula for linear integrals. So in this example, this first example that I want to consider on linear integral, we are asked to evaluate. We are asked to evaluate integral. We are asked to evaluate this integral. The first coordinate is 1, 1, then this is 4, 2. X plus y dy plus y minus x dx along, this is the first one. We want to evaluate this along a straight line. So we recall that since there are we have two coordinates along this line, then we recall that if we are to evaluate this line integral along this straight line, there are two coordinates. So when we have two coordinates, what is the equation of a straight line? The equation, an equation for a line joining, an equation for a line joining 1, 1 and 4, 2. Of course, this is S, and this is abscissa. This is ordinate, x coordinate, y coordinate, x coordinate, y coordinate. So this represents x1, y1. Here will be x2, y2. So if you want to evaluate this line integral along that straight line, we know that this line integral now is on xy plane. Okay, this is on xy plane. Then the equation of straight line is given as y minus y1 all over x minus x1 is equal to y2 minus y1 all over x2 minus x1. No other Cartesian coordinates. If you are given two coordinates and you are asked to find the equation of a straight line, we are going to use this. We have different form of equation of a straight line. When you are given the intercept and the gradients, the equation of straight line will be y is equal to mx plus c. If you are given the gradients and 1 point, the equation of the line is y minus y1 is equal to m into bracket x minus x1. But in this case now, we are given two coordinates. Without any gradient or intercept. So this represents the equation of a straight line. When we are given two coordinates, this will be the equation of a straight line. And since this will be the equation of a straight line, so from there now we substitute for the value of x1, y1, x2, y2, y1 minus x squared, y minus y1 is 1 all over x minus x1 is also 1. x1 is 1 is equal to y2 is 2 minus 1 all over x2 is 4 minus 1. That is what you are going to get. That is what you get. So if that is the case, then we have y minus 1 all over x minus 1 to be equal to 1 all over 3. If we cross multiply, we are going to get 3 into bracket y minus 1 to be equal to x minus 1. So we have 3y minus 3 to be equal to x minus 1. So we can actually say that 3y is equal to x. This is minus 3. By the time it crosses this equality sign, the sign will change to positive. Then we have x minus 1 plus 3. That will be x plus 2. That is what you are going to get. So that is what you are going to get. And of course, if you want to do this, if you want to evaluate this line integral along this, you realize that in this case now, it's either we rewrite everything in form of y dy or in form of x dx. So from this equation of straight line now, if we divide both sides by 3, divide 2 by 3, we are going to have y to be equal to this. So dy dx, if we differentiate in order to write this will be 1 all over 3. Differential of constant is 0. If you cross multiply, you realize that 3 dy is equal to dx. So please let's take note, because we are going to use this when we want to substitute back into what we are given. So we are going to use that when we want to substitute back into what we are given. So let's take note of that. Then if you want to write everything, all this line integral, if you want to write everything in form of y, if you want to rewrite everything in form of y, there's need for us to substitute for x. That is, from this equation, from here, we know that 3y is equal to x plus 2. If I make x the subject of formula here, we realize that 3y minus 2 is equal to x. So x can be equal to 3y minus 2. Let's take note of this. So how do we now evaluate this line integral along a straight line? This is what we do. We can rewrite everything and say we are substituting for the value of y now. Y is from 1 to 2. These are the coordinates. This is x1, y1, x2, y2. So the integral is going to range from y1, which is 1, to y2, which is 2. Then into brackets, what is x? Instead of x now, I'm going to substitute 3y minus 2. 3y minus 2, then plus y dy dx. What is ds? ds is same thing as 3 dy. I will say this multiplied by 3 dy. I want to write everything into bracket y. Then in this case now, minus x will now be, what is x? X is this. That will be minus 3y plus 2. Then this is dy. This is what I'm going to evaluate now. So if I evaluate that, then I will be able to come up with an exact value. At this point now, if you want to evaluate this along a straight line, is that we write everything in form of x. We use the coordinate of x, the s1, s2, or we write everything in form of y and use the coordinate of y. In this case now, I decide to rewrite everything in form of y. That is from 1, the coordinate from 1 to 3. So I'm going to change this to dx and dy. And if you want to follow this, if you want to change everything to dx, just say make y the subject formula here. You make y the subject formula. Then you substitute everything. So in this, from here now, we are going to have integral into brackets 3y 3y plus y, that is 4y. 3y plus y, that will be 4y. So here, this is what we are going to get. 3y plus y, that will be 4y. We are going to have 4y minus 2. 4y minus 2 multiplied by 3 dy plus here we are going to have minus 2y plus 2 dy. That's what we are going to get. So from there, let's see what we are going to get here. So the integral from there, we are going to have, this is 2, 1. If I multiply with what I have here, I'm going to get 12y minus 6. I want to multiply all through. 12y minus 6 minus 2y plus 2, everything into bracket dy. That's what I'm going to get. Then from here, I'm going to have integral 1 to 2 into bracket 10y minus 4 dy. If I integrate this, I'm going to get 10y. If I integrate 10y, that will be 10y squared all over 2. That will be 5y squared minus 4y from 1 to 2. That's what I'm going to get. Then we substitute for the value of y when y is equal to 2. 2 times 2, y squared, 2 times 2, 4. 4 times 5, this will be 20 minus, when y is equal to 1, 5 minus, this will be 20. That will be 20. That will be 20. Then we substitute for the other one. That will be 20 minus, when y is equal to 1, minus 8 minus into bracket 5 minus 1. That's what I'm going to get. Then here I'm going to have 12 minus 5 minus 4. I'm going to have 12 minus 1. The answer will be 11. So when we evaluate this line integral along a straight line, we will be able to get 11 as our answer. So the answer will be 11. The answer will be 11. We now move straight to the second one. We have been able to consider this. We want to also evaluate this line integral along a straight line. That is, in this case now, if you look at the property of line integral, it can be broken into two. So we first move from 1, 1 to 1, 2. That is, we move from this coordinate to this coordinate, and then move from this coordinate back to this second coordinate. So when we look at the third properties of line integral, we realize that we can actually do that. Third property of line integral actually permitted us to be able to do what I'm about to do now. So the second one. So what do we do here? What do we do if you want to evaluate along that line integral? So along the straight line. So along the straight line from 1, 1 to 1, 2. What do we have? You realize that from 1, this is x1, y1, x2, y2. You realize that there's no changes between x1 and x2. That is what we note. We realize that x is actually 1. So if we differentiate that, the x will be equal to 0. That is what we are going to get. Then the line integral will now be, since we are substituting for x, we are going to use that of y. But y here is 1 to 2. 1 to 2. I'm going to substitute the value of x and y. The value of x in this equation. Then into bracket, what is x here? X is 1. I have 1 plus y all over the x is 0. 0 plus y minus 0 dy. That's what I'm going to get. Then if you do that, that will be 1 to 2 into bracket. Of course, everything there will vanish because 1 plus y multiplied by 0 will be 0. So everything there will vanish. No, this is 1. X is 1. So we will be left with y minus 1 dy. So if I integrate this, what will I get? Integral. No, if I integrate this, I'm going to get y squared all over 2 minus y, ranges from 1 to 2. When I substitute the value of y, when y is equal to 2, this is what that will be 2 minus, that will be 2 minus 2 into bracket minus half minus 1. That's what I'm going to get. So half minus 1. That's what I'm going to get. At the end of the day, you realize that we are going to get this will be 0. Here will be 0 minus half minus 1 is minus half. Minus half. Minus is minus plus. So we are going to get half as the value there. So when we evaluate this straight line from 1 to 1 to 1, 2, we get half. We now move down. We now move from 1, 2, then to 4, 2. So what do we get there? So we have gotten half of the solution to B. So let's now go. We now move to the next one. Along the straight line, from 1, 2 to 4, 2. So in this case now, this is value of x1, y1, x2, y2. You realize that y1 and y2 are the same. So we say that if y is equal to 2, then dy will be 0. What do we now do here? We go back to this place. We use the value of x. We now substitute for the value of y and evaluate what we are given. So in this case now, we are going to have integral x is equal to 1 to 4. So wherever we see y, we change it to 2. So we have x plus 2. Then what is x plus 2 dx? Then plus y is 2. 2 minus x dy. Dy here is 0. So everything here will vanish. So from here, we are going to have integral from 1 to 4. X plus 2 dx. Everything here will vanish. Then if I integrate this, I'm going to have x squared all over 2 plus 2x from 1 to 4. From 1 to 4. Please let's note that the value from 1 to 1, 1 to 2 is half. So let's take note of that because we are going to have everything. We are going to have everything at the end of the day. So let's take note of that. So from there, what do we have here? we have, when we substitute 4 times 4, that's 16. 16 divided by 2, that will be 8, plus 2 times 4, 8, minus, we substitute for 1, half, that will be minus half, plus 2. That's what we're going to get. So here, we are going to have 16 minus 5 all over 2. Then at the end of the day, if we take the LCM, this is 2. That will be 32 minus 5. That will be 27 plus half. Yeah, all over 2. That will be the evaluation of the second one. So the required value now, the required value will now be, what is the value if you move, if you evaluate along the same line from 1,1 to 1,2, the value is half plus, then from 1,2 back to 4,2, that will be 27 all over 2. So if you add the two together, we have 28 all over 2, and the final answer will be 14. So if we evaluate this line integral along the straight line from 1,1 to 1,2 and then to 4,2, the value will be 14. The value will be 14. So we have been able to take care of this second value. We have been able to take care of the second value. We now move to the third one. We want to evaluate this same line integral along the parabola y squared is equal to 1. Of course, I want to assume that we are familiar with Cartesian coordinates and circle. We know the equation of a circle, the equation of parabola, hyperbola, and ellipse. So in this case now, this is what we want to do. We want to evaluate this line integral along this parabola. So what do we do? So along the parabola, we can actually differentiate this. We have 2 dy. If y squared is equal to dx, then 2y dy will be equal to dx. That is, if you differentiate this, that is what we are going to get. That is what we are going to get. So substituting x, if you not substituting for x in the line integral and use just the limits on y, we obtain what I'm about to write now. This is what we are trying to say. That the line integral, the formula for the line integral is given as 1,1, then 4,2, x plus y dx plus y minus x dy. This is what we are given. So along this parabola, y squared is equal to x. If we differentiate, we have 2y dx to be equal to dx. So what we now want to do is that we only substitute for y. So wherever you see dx here, we change it to 2y dx. That is integral from 1, which is y is equal to 1 to 2. This is y1, this is y2. Then if we want to do our substitution now, what do we do? So instead of x now, wherever I see x here, I change it to y squared. Wherever I see dx, I change it to 2y dy. That is, what I'm trying to say is that here we have x. Instead of x now, I'll change this to y squared plus y. Okay, instead of dx here, I'm going to change it to 2y. No, this is 2y dy. 2y dy plus y minus x dy. Then this is what I'm going to evaluate. This is what I'm going to evaluate now. Along the parabola, this is what I'm going to evaluate. So now let's just focus and look at what we are trying to do. So from here now, we have integral from 1 to 2. We have integral from 1 to 2. We have integral from 1 to 2. I will use this to multiply this. I will have 2y cubed plus 2y squared. 2y squared. Then I can bring it. No, here, instead of x here, I'll change it to y squared. This is y squared. Okay? That will be y squared. That is y squared. That's what we are supposed to do. So I can bring it, since this is the y dy, I can bring everything here. Plus y minus y squared, everything into bracket dy. That's what we get. Then we can collect the like terms here. Then we can collect the like terms 1 to 2 into bracket 2y cubed, 2y squared minus y squared. That will be plus y squared plus y dy. At this point, I can integrate. If I integrate this with respect to this, I'm going to get 2y quads all over 4. That will be y raised to power 4 all over y raised to power 4 all over 2 plus I have y cubed here all over 3 plus y squared all over 2. If you integrate this is what you get. Then ranging from 1 to 2. So from there, we substitute for the value of y. When y equal to 2 minus when y is equal to, when y is equal to 2 minus when y is equal to 1. So here I'm going to have 2 raised to power 4. 2 raised to power 4, that's 16. 16 divided by 2, that will be 8. This first one will be 8. Then 2 raised to, this is 8 plus 8 all over 3 plus 2 times 2, 4, that will be 2. Minus when y is equal to 1, that's half plus 1 over 3 plus half. That's what we are going to get. So from there now, from there, we are going to have this will be 10. Here will be 10 plus 8 over 3 minus, that will be 1 minus 3, 1 over 3. That's what we get. So what is 10 plus 8 over 3? 10 plus 8 over 3, we actually be, that will be 38. Here will be 38 all over 3 minus 2 thirds, 38 all over 3. 38 all over 3. So everything here, there is plus. That will be 4 all over 3. Then, if we look at this critically, we are going to have this to be 34 all over 3. Then this same thing as 11 whole number 1 all over 3. That's what we are going to get. So if we evaluate this line integral, along the parabola, this parabola y squared is equal to x, the value will be 11 whole number 1 all over 3. That is what we are going to get. So we are trying to we want to evaluate this line integral along 4 different patterns. The first one along a straight line, you have gotten the value of that. The second one along a straight line, but that is divided into 2. Please, I want you to, you can check my video on line integrals. Check the properties. Under the properties, you realize that it is possible to get this. Then the third one, we have also evaluated this line integral along the parabola. This parabola y squared is equal to x. Then finally, we want to evaluate the line integral along the curve, along this curve. We want to evaluate this line integral along this curve. The final one, along the curve, s is equal to 2t squared plus t plus 1. Then y is equal to t squared plus 1. So what do we do here? What do we do here? You recall that when we evaluate this line integral along a straight line, we derive a particular equation. We know that equation is that we know from the A part of the question that 3y is equal to x plus 2. We know this. We know that 3y from the first equation, we are able to generate something of this nature, if you recall. Then we substitute for the value of y. We also substitute for the value of s into this. So here we are going to have 3. What is y? T squared plus 1 is equal to x, 2t squared plus t plus 1, then plus 2. So here we are going to have 3t squared plus 3 to be equal to 2t squared plus t plus 3. So we now write everything together. We bring everything to one side. We have 3t squared plus 2t squared plus t to be equal to 3 minus 3. That will be 0. So here we have t squared plus t to be equal to 0. Then when we factorize that, we are going to have t into brackets t plus 1 is equal to 0. That's what we get. So we are going to get the value. No. Here, by the time this one comes in, this will be negative. This time will be positive. This will be negative. This will be negative. Okay. So 3t minus this is 2t. Then here I'm going to have minus. Here will be minus. So this place will be minus. Here will be minus. So simply this means that t is equal to 0 or t minus 1 equal to 0. So t is equal to 0 or 1. That will be the value of t. So if you are evaluating this line integral along this curve s and y in terms of t, then we are going to use this will represent the lower and upper bound. That is, we now say integral from 0 to 1 because we are differentiating now with respect to t. We are differentiating with respect to t. And if you want to do that, then before we write this, if this is dx, then if x is equal to 2t squared plus t plus 1, then y is equal to t squared plus 1. So what will be the x? The x will be what? If that is f, so the x will be 4t plus 1 dt. That's what you're going to get. The x will be this. Then dy, if you differentiate this, it's going to give us 2t dt. So if you differentiate that, that is what we are going to get. It's going to give us 2t dt. So if you want, the final step now is that we are going to write the line integral in form of t. We are going to change everything there in form of t. So the lower value of t is 0 to 1. So in this expression that we have here now, I'm going to substitute the value of x in terms of t plus the value of y in terms of t, then dx in terms of t and dy in terms of t. And if you do that, this is what we are going to get. So x, what is x? X will now be equal to 2t squared plus t plus 1, okay, plus y is equal to t squared plus 1. That's what we are going to get there. Into brackets, dx in terms of t will be 40 plus 1 dt. Then plus, I'll go to the second one, into brackets, y is t squared plus 1 minus, into brackets, x is 2t squared plus t plus 1. Then dy is same thing as 2t dt. That's what we are going to get there. So we are going to expand what we have there. We are going to expand what you have there. So we have integral from 0 to 1. Here, 2t plus 2t squared plus t squared. That will be 3t squared. 3t squared. Okay. 3t squared, then plus t plus 2. That's what we have. Into brackets, 4t plus 1 dt plus, let's also open up here, t squared. Let's open up in the second one. This is t squared minus 2t squared. That will be into bracket minus t squared, then minus t, 1 minus 1 will cancel out, then 2t dt. That's what we are going to get. Okay? That is what we are going to get. That's what we are going to get. But then we can actually open up here. Or if you don't want to stress ourselves, let us go ahead and substitute for the value. Let's integrate directly. We can integrate and substitute for the value. If you don't want to stress ourselves there, we can integrate directly. Or let me expand. If we expand here, is 0, 1. So I'm going to have 3t multiplied by this. That will be 12t cubed. I'm going to have 12t cubed. Can we get any other 12t? Yes, I'm going to have 12t cubed. I will have 12t cubed plus 3t multiplied by 1. That's 3t. Then that will be plus 70 squared. Okay. Then I'm going to the plus 70 squared. This is 1. Here is 1. Here is 1. Okay. Plus 70 squared. Then we'll come back to this space. That will be t plus, that will be plus 5t plus 2. This is what I'm going to get here. Plus 2. Okay. Minus, if I open up here, I'm going to get minus, that will be plus 2t cubed minus t squared minus t squared minus 2t squared minus 2t squared. Everything into bracket dt. Everything into bracket dt. So from there, we can actually collect the like terms to have is 0 to 1. 12t. So there we are going to have 12t. 12t minus, here will be minus. This is minus t squared. So 12t minus, that will be 10t cubed. Then 70 minus this plus 5t squared. Okay, plus 5t plus 2. Everything into bracket dt. That's what you are going to have. So that's what you are going to have. No, here will be 9. Because when we have this is 40. Okay, here will be 40. Here will be 40. No, here will be 80 plus 8. Here will be 90. We are going to have 90 here. Here will be 90. So we have 90 here. This place will be 90. Just try and go through it. Go through all the steps and see that we didn't make any mistake. But I don't think there's any mistake there. Just try and go through the step. Okay? We're try and expand it correctly. So from here, if I of course, I'm going to substitute. I will integrate this now. Here I'm going to have 10 t quarts all over 4. Then I'm going to have 10 t quarts all over 4. That is, here will be 10 t quarts all over 4. So that will be 10, 5t raised to power 4 all over 2 plus 5t cubed all over 3 plus 9t squared all over 2 plus 2t is 0 to 1. Of course, I will only substitute for the value of when t is equal to 1. When t is equal to 0, everything here will vanish. Everything here will vanish. So we substitute for t is equal to 1. That will be 5 all over 2 plus 5 all over 3 plus 9 all over 2 plus 2 all over 1. Into bracket minus 0. So what do we get there? We will find the LCM here. LCM will be 6. Okay? 2 in 6, that is 3. 3 times 15 plus 3, 2, 10 plus 2 here, 3 times 27 plus 12. Then at the end of the day, this is 39, 49, 64. We are going to have 64 all over 6. So we have 64 all over 6, which is something as 32 all over 3. Then the final answer will be 10 whole number 2 all over 3. That will be the final answer. So if you evaluate this along the curve, this curve in form of t, then we are going to get the final answer to be 10 whole number 2 all over 3. So underline it, this example now, we have to evaluate the line integral as we have it on the board along 4 different means. The first one along a straight line, which we have done. The second one along a straight line, but that straight line, there's another point between, let's say, A and B. And there's another point along that C, that is from 1, 1 to 1, 2, and then to 4, 2. Then we also have to evaluate it along this parabola, y squared is equal to s. Then the final one is to evaluate it along the curve, which we have done. So we are going to continue from here in our next class. Thank you.